Before there were stars, before space had form, before even time itself dared to move, there was only the silent dark, holding the first spark of everything that would ever exist. But what came before the very first moment?
Welcome to Sleepster, the place where time softens, the stars listen, and every story is a slow river carrying you deeper into the quiet. Before we drift further, tell me, where in the world are you listening from, and what time is it there right now?
What if the way we speak about beginnings is flawed from the very start? What if there was no before at all? What if time itself was not a stage that had always been waiting in the dark for the actors of matter and light to step upon it, but was instead born with them, stitched into the same first breath? It is a thought that bends the mind in quiet ways, because it asks us to let go of a picture we have been carrying since childhood. The picture of a line with a left side and a right side, a neat arrow pointing from past to future, with a dot we call the present and an invisible horizon we call the past before it. But physics whispers a softer, stranger thing, that this arrow may not stretch back forever, that time might be as much a creation as the galaxies themselves, not a backdrop, but an ingredient. In that way, to ask what was before time is like asking what is north of the North Pole. It is a question that feels natural and yet dissolves in your hands when you try to hold it. If time had a birth, then there is no before to stand upon. The very concept of earlier loses its meaning. Our minds are used to the comfort of cause and effect, of one thing following another, and so we instinctively reach backward, looking for the first domino. But in the earliest moments of the universe, there may have been no dominoes, no chain, no flow, only a kind of pure state, unmeasured and unmeasurable. Physicists give this earliest imaginable instant a name, Planck time, so short a span that numbers themselves feel useless in describing it. A fraction of a second so fine it would take 100 billion trillion of them to make a single blink. And even this, they say, is not before the universe, but the first sliver of it. We can think of it like the unfurling of a map that had never been drawn. Before the map appears, there is no terrain to travel. Before the fabric of time and space came into being, there was no somewhere and no when in which anything could happen. It was not empty, because even the word empty assumes a container, but something stranger, outside the grasp of all our normal words. And yet, even in this strangeness, the seeds of everything familiar were already there. The forces that would one day pull mountains from the crust of the earth, the particles that would fuse in the bellies of stars, the quiet laws that would, in their patience, give rise to rivers, to seasons, to memories. It is unsettling to think that the whole history of everything, every ocean wave, every breath, every stone, is confined within this thing we call time, and that outside it, in whatever outside might mean, our rules simply vanish. We imagine ourselves peering past the beginning, but maybe there is no edge to peer over, only the recognition that edges themselves are features of this reality, not requirements of existence. Perhaps the deepest truth is not that we began at some particular moment, but that moments themselves began, carrying us with them like a river that springs from a hidden spring. Some cosmologists suggest that time might be more like a bubble forming in a vast foam, not an endless road, but a local swell in something larger, something timeless. In such a picture, our entire universe is like a pearl growing in an ocean we cannot measure, and the question, what was before, becomes a question about that ocean, what it is, why it is, if is even the right word. Others imagine cycles, where time folds back on itself in loops so grand that beginnings and endings lose all distinction. And still others wonder whether the very act of asking about before is a sign of how deeply we are woven into time's fabric, unable to imagine a state where it does not exist because our thoughts themselves are measured in its flow. And so we are left with a strange humility. The story of the universe may not begin with a spark in the dark, but with the dark itself learning to be measured, with the first tick of a clock that had never ticked before. It is not that something happened before time began. It is that there was no before for anything to happen in. That is the quietest mystery of all. Not an answer, but a gentle erasure of the question itself. And yet, if the first tick marked the birth of all things we know, what was it that wound the clock? Before the first second could stretch itself into being, before even the faintest heartbeat of time could be felt, there was a state where energy was present, yet unmeasured, a restless potential without minutes to contain it or hours to divide it. A moment, though even the word moment fails here, when the clock of the universe was not yet wound, and in that stillness, if we can call it that, everything we know and everything we will never know waited in a kind of perfect suspension, not silent exactly, but without the ticking rhythm that gives our lives a sense of forward motion. In this earliest imaginable sliver, the scale of time is so small that ordinary numbers lose their usefulness, and physicists speak instead of Planck time, an interval so brief that it defies the human sense of sequence, so tiny that 100 billion trillion of these units would pass in the space of a blink. And within this scale, the universe is more like a shimmering uncertainty than a place, a sea of quantum foam where space itself flickers in and out, bubbling, folding, and evaporating before any stable reality can take hold. And in this foam, the concepts of before and after dissolve, replaced by a restless fluctuation that has no preference for either. Quantum foam, if we trust the mathematics, is not made of anything in the way a rock or a cloud is made, but is instead the restless surface of space-time at its smallest scale, where the uncertainty principle allows energy to briefly appear and vanish, creating ripples so faint and so fast that they are gone before they can be said to exist. And yet, this chaotic bubbling may have been the canvas upon which the first strokes of reality were painted, though at this point neither matter nor time was distinct from the fabric in which it swam. It is here that the impossibility of separating matter from time becomes clear, for in our universe they are not independent threads, but strands of the same weave, and if time had not yet unfolded, matter could not yet settle into form, and without matter, time itself had nothing to measure, nothing to pace itself against, no change to count. So both were trapped together in an unborn state, like dancers waiting for the first note of a song that had not yet been written. And in that strange partnership, perhaps the potential for everything, stars, oceans, forests, even thoughts, was already there, just not yet awakened. We can try to picture it, though our minds are built from the very time we are trying to imagine away, and so the act of imagining bends inward upon itself,
folding into paradox, because we are creatures of seconds and minutes, and here there were none. No dawn to wait for, no past to remember, only a state in which the laws we now take as constant had not yet emerged, as if the rule book of reality itself had not been printed, and the pages were still blank, yet humming faintly with the ink that would one day give them meaning. Perhaps this is why physicists speak of the earliest universe not as a place or a moment, but as a state where energy is the only certainty, but energy without direction, without an arrow to follow, drifting equally toward all possibilities. And maybe, in this drifting, there was already a kind of whisper, the first hint that change would come, that the clock would be wound, and with its first tick, the long story of expansion and cooling, of formation and collapse would begin, carrying us all the way to now. And yet, as we try to hold this image, it slips from our grasp because the truth of this early state is not in what we can see, but in what we cannot measure, in what refuses to be placed on the line we call history, and it leaves us with a quiet question. If time and matter were born together, what hand turned the key? What presence or absence set them both in motion? And if that first winding of the clock was not the beginning of everything, then perhaps it was simply the beginning of beginnings.
We arrive at the edge of the unimaginable, when the universe took its first measurable breath, when zero transformed into something more than nothing, and the clock of reality began to tick. Before this instant, there was no before. The language of cause and effect, so comfortable to our minds, dissolves in this strange and fragile dawn. Physicists speak of Planck time, a slice of existence so brief it cannot be halved, so short that light itself could barely stretch across the smallest imaginable fraction of space. This is not merely a small number, it is the limit of meaning for what we call time. Anything smaller, and the word before becomes meaningless. In that incomprehensibly brief instant, after the birth of the cosmos, the laws that now govern reality were molten, flexible, undefined. Gravity had not yet settled into the gentle pull that holds worlds in orbit. The forces that would later shape galaxies and atoms were tangled together in a single, unbroken thread. The universe was a storm of pure energy, a luminous sea without shape or distinction, yet filled with the seeds of everything that would ever be. This moment was not silent, not in the sense we understand silence. Instead, it was filled with the roar of existence itself, an invisible vibration, a tremor in the nothingness, as space expanded faster than light could dream of traveling. We can never witness this with our eyes, but the mathematics whispers its story to us. A story of pressure and temperature so extreme that no solid thing could survive. This was not yet the kingdom of stars or planets. It was the raw forge from which all things would someday be born. And then, almost instantly, change began. Space itself was stretching, an inflation so rapid it took the size of the universe from smaller than an atom to the scale of galaxies in less than a blink. Time, still a newborn, was now moving forward in a single, irreversible direction. There was no turning back. The first particles, quarks, electrons, began to flicker into being, brief sparks that would later join to form the first atoms. This was the first
tick. The moment when the river of time found its bed and began to flow. The cosmos, once only potential, now had a past and a future. And in that future, countless billions of years away, a creature called a human would stand beneath the night sky, wondering what it was like to witness this birth. We cannot witness it, but in some quiet way, we remember it. For every atom in our body, every photon that ever touched our skin began its journey here, in the heartbeat, when time first began to move. There is a quiet strangeness to the idea that something as intangible as light carries weight, not in the way a stone presses against your palm, but as a silent burden woven into the threads of space-time itself, bending reality with every photon's journey, curving the very fabric of the cosmos without a whisper or a touch. In the early days of physics, light was imagined as a ghost, a perfect traveler, unburdened by mass, flitting across the emptiness at the fastest speed allowed in the universe. But as Einstein's equations stitched together space, time, and energy, they revealed a truth more unsettling. Energy is mass, and mass is energy, bound in the equation E equals mc squared, like two faces of the same coin. And light, though massless in the conventional sense, holds energy that bends the geometry of reality itself. It means that a beam of sunlight slipping through your window is not merely painting warmth on your skin, it is exerting pressure, an invisible nudge called radiation pressure, so delicate that it cannot be felt, yet strong enough over millennia to shape the damps of dust and ice around distant stars. In the weightless void, light can push, corral, and even sculpt the destinies of worlds. This is why galaxies do not just shine, they pull and twist with the glow they emit, their light altering the paths of wandering particles, their energy contributing to the hidden bookkeeping of gravity's endless account. Even in the vacuum between stars, where nothing seems to happen, light is still negotiating the shape of the void, whispering to space-time how it should curve. And here lies a paradox, quiet but profound. If light can bend space, and space tells light where to go, then light is both the traveler and the mapmaker, moving through a terrain it simultaneously sculpts. Around black holes, this relationship reaches an extreme, with photons trapped in perfect orbits, a ring of light circling endlessly, neither falling inward nor escaping outward, bound forever to a horizon from which even time itself cannot retreat. In this way, light becomes more than illumination, it becomes architecture, a silent mason of the universe's structure. Without its pressure, without its subtle weight, the cosmos would have evolved differently. Stars would burn, but their surroundings would remain unchanged, their influence diminished. Instead, each flash of light, each wave of energy leaves behind a fingerprint in the geometry of existence, shaping futures that will play out millions or billions of years later. It is strange to think that every photograph ever taken, every sunset we have ever watched, every flicker of a candle's flame is an expression of this same universal law, that beauty and physics are at their core inseparable, both bound to the weight of light. The shimmer of an aurora above the poles, the glare of a comet's tail, the glow in the eyes of someone you love, all of them bending space by imperceptible degrees, contributing to a gravitational conversation that will never end. And so, when we think of light,
we must think not only of speed, not only of brightness, but of gravity. The way a ray of sun leans ever so slightly toward the earth, the way a star's radiance nudges the orbits of far-off worlds. It is a weight we cannot lift, a burden we cannot touch, but it is always there, pressing gently against the cosmic stage, reminding us that even the fastest thing in the universe is still tethered to the slow pull of gravity's hand. This is the weight of light, unseen, unfelt, yet inescapable, a reminder that in this universe, even the intangible leaves an imprint.
Before there was light as we know it, there was only the dense, searing aftermath of creation, a universe still thick with energy and matter so tightly woven together that nothing could move freely, a place where photons, the carriers of light, were trapped, endlessly colliding with particles, unable to travel in a straight line, their paths tangled in a cosmic crowd, the early cosmos like an endless fog where no beam could pierce the darkness, where vision itself was impossible because space had not yet learned to let light breathe. For hundreds of thousands of years, this was the state of existence, a blinding brightness that was paradoxically invisible because light that cannot travel is not light at all, but merely energy waiting for release. And in this vast primordial ocean of particles, time stretched on, slow and heavy, as the newborn universe cooled. And with cooling came change. Particles slowed just enough for protons and electrons to find each other, forming the first neutral atoms, mostly hydrogen and helium. And in that moment, something extraordinary happened. The fog began to lift. The photons were no longer constantly scattered, and for the first time in cosmic history, light could move freely, unhindered, crossing the emptiness between atoms. This was the event we now call recombination, though the name feels far too mechanical for what it truly was. A liberation, a cosmic dawn, the moment when the universe opened its eyes, when darkness and light became distinct concepts, when the first photons began their endless journey, some of which are still traveling now, billions of years later, whispering the story of that moment through what we call the cosmic microwave background, the faint afterglow still woven into every corner of the night sky. Imagine standing, if such a thing were possible, at that threshold. Before you, the universe is opaque, a glowing wall of blinding plasma. Behind you, it stretches into sudden clarity, transparent and open, the light moving at last through space, carrying the newborn vision of reality itself, every particle suspended in a vast silence that is no longer bound by the same blurring chaos. The universe entering a new phase where structure can begin to form, where matter can begin to gather, where the seeds of stars and galaxies can finally be sown. The birth of light was not merely an event in physics, it was the first act of storytelling in the cosmos. Before this, there was no record that could endure, because without light, nothing could be seen, nothing could be traced. But once photons began to move unimpeded, they carried with them the memory of their origins, each one a messenger from the first moment of sight, and to this day we still catch them in our telescopes, still listen to their ancient message, still let them paint the map of where we came from. And so, in the great silence of space, in the stillness between the stars, when we speak of light being born, we speak of more than illumination. We speak of the first freedom, the first signal, the first proof that the universe was not just a formless storm, but a place where journeys could begin, where paths could be traced, where the story of everything could finally unfold in the language of photons, a language we are only just beginning to fully understand. Long before the notion of galaxies and planets took form, the young universe was an ocean of restless energy, a shifting canvas where the first subtle differences began to appear. Ripples faint and scattered, born from quantum fluctuations that had been stretched and frozen by the great inflationary swell. And these tiny irregularities, so slight they could have been mistaken for the universe's own quiet breath, were in truth the seeds from which every future star, every cluster, every world, and every living thing would one day emerge, their patterns etched invisibly into the glowing plasma that filled all of space, yet carrying in them the destiny of entire cosmic architectures. In this warm and blinding expanse, photons roamed freely, endlessly scattered by electrons and protons in a dense and glowing soup. And yet within that apparent chaos, the pull of gravity began its patient, imperceptible work, coaxing matter ever so gently toward regions where density was slightly higher than the surrounding sea. And though the differences were unimaginably small, mere 1 part in 100,000 variations, they were enough for gravity to claim a foothold, setting in motion a slow and inevitable gathering of mass, a process that would take hundreds of millions of years to show its first grand results, but which, in this moment, had already begun its silent orchestration. The universe in this era was almost entirely uniform, smooth as a polished sphere when viewed from afar. Yet deep within its uniformity lay the faint signature of structure to be, a map written in temperature variations too subtle for any primitive eye to notice, but preserved in the radiation that would one day cool and drift through space as the cosmic microwave background, carrying with it the oldest photograph of reality itself. And though no stars yet burned, and no galaxies yet spun, the blueprint for them all was already drawn, woven into the interplay of matter, radiation, and gravity, like an invisible score for a cosmic symphony that had not yet reached its first note. As expansion continued, the universe's temperature fell steadily, sliding down from the blazing heat of billions of degrees toward cooler, calmer thresholds. And with each fraction of a degree lost, the interactions between particles changed ever so slightly, allowing protons and neutrons to cling together into atomic nuclei, a quiet preparation for the time when electrons would finally settle into orbit around them, creating the first true atoms and opening the way for light to move unhindered through space. But that moment was still hundreds of thousands of years away, hidden beyond the horizon of the present age, like a dawn that could be sensed but not yet seen. For now, the first shadows of structure lived only as density ripples, faint depressions in the otherwise smooth landscape of space-time. And yet these gentle beginnings contained all the architecture to come. For without them, the universe would have remained an endless, featureless mist, never giving birth to the patterns and shapes that would define the cosmos. And so in this quiet, in this patient pause before the first stars ignited, the foundations of all future complexity were being laid, not through sudden creation, but through the unhurried, deliberate pull of gravity, whispering to matter that it was time to begin the long gathering that would one day light the heavens. There is a strange elegance in the way the universe arranges itself, an order that hides beneath the chaos, a geometry that persists even when the surface seems wild and unpredictable, as if an invisible architect whispers instructions to every particle and wave, ensuring that no matter how far they wander, they never lose the balance that binds them together. In the early universe, when temperatures burned hotter than the core of 1,000,000 suns, the laws of physics were not yet separated into the distinct rules we know today. There was no difference between the force that holds an atom together and the one that bends the path of a planet, for they were all part of a single unified field, a symmetry so complete that even time and space themselves seem to mirror each other in a flawless reflection. Yet perfection, in the strange logic of the cosmos, is unstable. For the universe does not seem to love stillness. It loves movement, transformation, and the shattering of what once seemed eternal. The symmetry began to break, not through violence, but through a gentle, inevitable cooling. As if the universe were a great pond that once shimmered in perfect calm, but slowly began to ripple. Each ripple becoming a rule, a law, a force, shaping reality in countless new ways. In that symmetry-breaking moment, gravity pulled itself apart from the other forces, claiming its role as the sculptor of stars and the weaver of galaxies, while the strong nuclear force took on the task of binding the tiny hearts of matter, the protons and neutrons, so tightly together that even the most powerful explosions in the cosmos could not tear them apart. The weak nuclear force became the quiet alchemist, guiding the transformation of particles in radioactive decay and fueling the fusion inside the first stars, while electromagnetism emerged as the artist of light, soundless yet brilliant, giving the cosmos its glow. These four forces, born from the fracture of the original perfect symmetry, are the reason the universe is not just an infinite featureless cloud of energy. They are the reason atoms can form, stars can burn, planets can orbit, and life can awaken to wonder about its own origins. Without the breaking of that symmetry, there would be no contrast, no structure, no story to tell. And yet, deep within the mathematics of the universe, there are hints that this symmetry was never truly lost, only hidden, folded away in dimensions we cannot see, woven into the quantum fields that still hum beneath everything. Physicists search for this hidden order like archaeologists searching for the ruins of a lost civilization, convinced that if they find it, they will glimpse the original blueprint of reality itself. Perhaps the silent architect still works in the background, guiding the dance of galaxies and the spin of quarks, reminding the universe of its first design even as it continues to evolve into forms stranger and more beautiful than we can imagine. Perhaps every law of physics, every constant of nature, every pattern in the spiral of a galaxy or the unfolding of a fern leaf is just an echo of that perfect balance that once was, and might still be, hidden in the deep. If the symmetry could be restored, if we could wind the clock of reality backward and watch every force and particle merge into that first unified moment, what would we see? Would it be light, sound, a silence beyond silence, or something our senses have no name for? The answer remains a mystery, a fragment of the original design left for us to ponder, while the silent architect continues its work in the unseen places where the laws of reality are written. Before there was light in the way we understand it, there was something stranger, a shimmer without a source, a glow without photons, a kind of presence that was not yet illumination. Imagine a universe still blind to itself, unable to see or be seen, yet already pulsing with the seeds of radiance. This was not the blaze of stars, nor the gentle night of dawn, but an entirely different phenomenon, a silent prelude to the first true light.
In those first instants, the universe was opaque, like fog so dense that nothing could pass through it freely. Photons, the particles of light, existed, but they were trapped, constantly colliding with charged particles, ricocheting endlessly, unable to travel in straight lines. Every direction was blocked. Every attempt to escape met with resistance. It was a prison of pure energy, and light had not yet learned the meaning of freedom. This era, known now as the Cosmic Dark Ages, was not truly dark in the sense of total absence. Instead, it was filled with the restless energy of photons bound to matter. Space was a blinding storm, but only from the inside. There were no eyes to witness it, no beings to measure its brightness, and so it might as well have been nothing at all. The universe was pregnant with light, but it could not yet give birth to it. To picture this is to imagine a vast ocean, not of water, but of particles. Electrons and protons swimming in a turbulent sea. Photons darted among them like restless fish in an overcrowded tank, their paths bent and broken with every collision. Time itself ticked in unfamiliar rhythms, and in this early fog, nothing could cast a shadow, for shadows require light that can travel. Then, slowly, the universe began to cool. This cooling was not like the drop of temperature we feel in the evening air. It was a cosmic unraveling. As expansion stretched space, the energy density fell, and the furious collisions grew less frequent. Protons began to capture electrons, forming the first stable hydrogen atoms. This was recombination, a word that sounds gentle, almost domestic, yet marked one of the greatest transformations in cosmic history. With electrons locked into orbits around protons, the photons were finally released. No longer did they ricochet endlessly. For the first time, they could move freely across space, carrying information, carrying the story of what the early universe had been. This was the moment when light, as we understand it, was born. Though even then, it was not the golden light of stars, but a uniform glow, stretched and softened by the continued expansion of the universe. We see that glow today as the cosmic microwave background, a whisper from 13.8 billion years ago. Every microwave photon that reaches our instruments is a survivor from that ancient release, traveling across eons without losing the memory of its birth. It is the oldest light we can detect, and it tells us that the universe, in its earliest visible moment, was astonishingly uniform, with only the faintest ripples, the seeds from which all galaxies, stars, and planets would eventually grow. And yet, in that moment of liberation, the universe still lacked the kind of light that inspire warmth or wonder. The first stars had not yet formed. There were no suns to rise and fall, no beams to pierce the dark. For hundreds of millions of years after recombination, space was filled with hydrogen and helium gas, thin and cold, awaiting the gravitational pull that would gather it into the first stellar furnaces. The first true light, the kind that could cast shadows, ignite worlds, and be seen across the void, was still waiting to be born. But without this earlier hidden radiance, without the quiet release of photons into open space, there could have been no stars, no galaxies, no us. Light had to be free before it could be brilliant. It is strange to think that the light which first escaped was not meant for eyes, yet it became the foundation for everything we see. It reminds us that even the most radiant things begin in silence, and that sometimes The first step towards brilliance is simply learning how to move through the dark.
Before there was light, in the way we understand it, there was something stranger. A shimmer without a source, a glow without photons, a kind of presence that was not yet illumination. Imagine a universe still blind to itself, unable to see or be seen, yet already pulsing with the seeds of radiance. This was not the blaze of stars, nor the gentle light of dawn, but an entirely different phenomenon, a silent prelude to the first true light. In those first instants, the universe was opaque, like fog so dense that nothing could pass through it freely. Photons, the particles of light, existed, but they were trapped, constantly colliding with charged particles, ricocheting endlessly, unable to travel in straight lines. Every direction was blocked, every attempt to escape met with resistance. It was a prison of pure energy, and light had not yet learned the meaning of freedom. This era, known now as the Cosmic Dark Ages, was not truly dark in the sense of total absence. Instead, it was filled with the restless energy of photons bound to matter. Space was a blinding storm, but only from the inside. There were no eyes to witness it, no beings to measure its brightness, and so it might as well have been nothing at all. The universe was pregnant with light, but it could not yet give birth to it. To picture this is to imagine a vast ocean, not of water, but of particles, electrons and protons swimming in a turbulent sea. Photons darted among them like restless fish in an overcrowded tank, their paths bent and broken with every collision. Time itself ticked in unfamiliar rhythms, and in this early fog nothing could cast a shadow, for shadows require light that can travel. Then, slowly, the universe began to cool. This cooling was not like the drop of temperature we feel in the evening air. It was a cosmic unraveling. As expansion stretched space, the energy density fell, and the furious collisions grew less frequent. Protons began to capture electrons, forming the first stable hydrogen atoms. This was recombination, a word that sounds gentle, almost domestic, yet marked one of the greatest transformations in cosmic history. With electrons locked into orbits around protons, the photons were finally released. No longer did they ricochet endlessly. For the first time, they could move freely across space, carrying information, carrying the story of what the early universe had been. This was the moment when light, as we understand it, was born. Though even then it was not the golden light of stars, but a uniform glow, stretched and softened by the continued expansion of the universe. We see that glow today as the cosmic microwave background, a whisper from 13.8 billion years ago. Every microwave photon that reaches our instruments is a survivor from that ancient release, traveling across eons without losing the memory of its birth. It is the oldest light we can detect, and it tells us that the universe, in its earliest visible moment, was astonishingly uniform, with only the faintest ripples, the seeds from which all galaxies, stars, and planets would eventually grow. And yet in that moment of liberation, the universe still lacked the kind of light that inspires warmth or wonder. The first stars had not yet formed. There were no suns to rise and fall, no beams to pierce the dark. For hundreds of millions of years after recombination, space was filled with hydrogen and helium gas, thin and cold, awaiting the gravitational pull that would gather it into the first stellar furnaces. The first true light, the kind that could cast shadows, ignite worlds, and be seen across the void, was still waiting to be born. But without this earlier hidden radiance, without the quiet release of photons into open space, there could have been no stars, no galaxies, no us. Light had to be free before it could be brilliant. It is strange to think that the light which first escaped was not meant for eyes,
yet it became the foundation for everything we see. It reminds us that even the most radiant things begin in silence, and that sometimes the first step towards brilliance is simply learning how to move through the dark.
Before there were eyes to witness them, before there were minds to name them, colors bloomed in the universe like silent music, unfolding in wavelengths no one would ever see. It began as a dance between light and matter, a quiet conversation between particles that had no audience, yet spoke in the language of frequency and energy. In the earliest days, light was not the light we know now. It was stretched and bent, scattered and absorbed in a way that would make even the idea of blue or red meaningless. The universe itself was still finding the rhythm of expansion, and in that rhythm, the seeds of color were sown. The first stars, enormous and short-lived, painted their surroundings in fierce ultraviolet strokes, light so intense it could split atoms and tear apart the fragile bonds of forming matter. These colors were invisible to any future human eye, too sharp, too energetic, too dangerous, yet they set the stage for all colors that would follow. As these stars burned and collapsed, they forged heavier elements, scattering them into space like pigments waiting to be mixed. The empty canvas of the cosmos began to hold the potential for more subtle shades. Over millions of years, clouds of gas and dust began to swirl, lit by the gentler glow of younger stars. Hydrogen and helium whispered in pale pinks, while oxygen exhaled blues so faint they could only be caught by the patient gaze of time itself. These clouds, stretching for light years, became both nurseries for new stars and galleries for the universe's earliest paintings. Yet still, there was no one to see them. These masterpieces hung in the dark, their beauty a secret kept by space itself. When planets began to form, colors found new canvases. Some worlds were wrapped in thick blankets of orange haze, others shimmered with icy white plains, while others glowed in the eerie green of alien atmospheres. Yet for billions of years, this art was wasted on the void. Colors lived and died without ever being named. On Earth, before life had eyes, the seas shimmered in strange chemical blues, and the land was washed in tones shaped by minerals, sunlight, and the thin atmosphere. It was a world already rich in color, yet blind to its own beauty. Only when evolution crafted vision, the delicate machinery of eyes and the brain's gift of interpretation, did the silent colors of the cosmos begin to find witnesses. And even then, what we see is but a fraction. The spectrum is vast, an infinite gallery where most of the paintings remain hidden from us, their wavelengths too short or too long to be touched by human perception. Bees see patterns in flowers invisible to us. Snakes sense the heat of prey in infrared. The night sky above us glows with ultraviolet we cannot feel. The first colors that were never seen still exist. They pass through us every day, carried in the sunlight, hidden in the shimmer of distant galaxies, woven into the structure of reality. We walk through them without knowing, wrapped in a coat of invisible rainbows. And perhaps, somewhere, in another kind of mind, in another kind of body, the universe is seen in its entirety. Every wavelength, every hidden shade, every secret hue that we can only imagine. Our colors, the ones we name and love, are only a sliver of what the cosmos has to offer. Yet even this small slice is enough to make life worth seeing, worth remembering, worth keeping our eyes open. Somewhere out there, in the silence beyond our reach, colors are still blooming in the dark, and they do not care whether anyone is watching. Before the first stars, the universe was a cold and endless sea of darkness, a vast expanse where hydrogen and helium drifted like silent ghosts, waiting for the moment they would ignite and bring light to the cosmos. The darkness was not empty. It was pregnant with possibility, with matter gathering in invisible hands shaped by gravity. Over millions of years, tiny fluctuations in density, remnants of quantum ripples from the universe's earliest breath, began to pull clouds of gas together. These clouds were enormous, stretching across light years, yet still too thin for light to be born. Gravity, patient and unyielding, pressed the gas tighter and tighter. With every collapse, atoms began to jostle more violently, and the temperature within those clouds climbed. What had been cold and silent started to hum with energy. The first stars were not gentle. They were colossal, far larger than most stars we see today, tens or even hundreds of times the mass of our Sun. This was because the early universe held no heavier elements, only pure hydrogen and helium, which allowed these giants to form without resistance from heavier matter. As the gas compressed into a dense core, the heat soared past millions of degrees. Inside, a silent but monumental shift occurred. Nuclear fusion began. Hydrogen atoms were squeezed together so tightly that they fused into helium, releasing torrents of light and heat. In that instant, the darkness that had ruled since the Big Bang was pierced. The first stars blazed into existence, flooding the cosmos with light for the first time. These stars lived fast and died young. Their massive size meant they burned through their fuel in only 1,000,000 years, a blink compared to the Sun's 10-billion-year lifespan. But in their short lives, they transformed the universe. Their searing light reionized the surrounding hydrogen, clearing away the cosmic fog that had veiled the early cosmos. Space, once opaque, became transparent, and the universe began to take on a structure we could someday see. Yet their greatest legacy lay in their deaths. When these titans reached the end of their fuel, they exploded in supernovae so powerful that they forged the first heavy elements: carbon, oxygen, iron, the raw materials for planets, oceans, and eventually life. Scattered across space, these elements seeded the next generations of stars, giving them more complex chemistry. Without those first giants, the universe would have remained sterile, a place of light, but without the possibility of life. The birth of the first stars was not just a scientific milestone, it was the universe's first act of creation in color. It was the moment when light became more than a byproduct of heat. It became a storyteller, carrying across billions of years the tale of the cosmos's awakening. Every starlit sky you have ever seen is a descendant of that moment. In the silence before the first stars, the universe was waiting, gathering strength. And when the first flames ignited, they were more than fire. They were the first heartbeat of a living cosmos.
Before there were galaxies, before the elegant spirals and vast clusters took their place upon the grand stage, the universe lay in a quiet haze, a diffuse mist of hydrogen and helium that filled the infinite dark. It was an age without sharp edges, without blazing lights. The cosmic background glow still lingered like the fading embers of a fire long since lit, but its warmth had cooled, slipping into a spectrum invisible to the first atoms. The darkness was not empty, it was simply patient. This was the cosmic dark age, a span of time when no stars yet shone, when the universe's matter was spread thin across an ever-expanding stage. Imagine a world wrapped in a fog that has no source, no wind to stir it, no horizon to break it, just an unbroken ocean of potential waiting to ignite. The atoms drifted, pulled only by the subtle gravity of tiny fluctuations seeded in the earliest instants of time. It is in this stillness that the future began to breathe. Small knots of gas began to gather, drawn by the faintest whispers of gravity. At first, these gatherings were fragile, mere shadows of what would one day become galaxies. They grew slowly, imperceptibly, like dew forming in the cold of dawn. Inside these invisible cocoons, matter compressed. Hydrogen atoms, the simplest building blocks, pressed closer together. Heat began to rise not from fire, but from the relentless squeeze of gravity folding space upon itself. The process was delicate. If the balance tipped too quickly, the structure would collapse into nothing. Too slowly, and the spark of creation would never come. Then, somewhere, in some nameless corner of the early cosmos, the first fusion was born. The atoms danced into new forms, hydrogen becoming helium in an explosion of light. In that moment, the Dark Age ended, pierced by the light of the very first stars. They were nothing like the sun we know. They were giants, short-lived titans that burned impossibly hot, flooding the universe with ultraviolet light. This light did more than illuminate. It changed the very nature of the cosmos. The radiation from these first stars began to strip electrons from surrounding atoms, ionizing the gas, breaking apart the ancient calm. The universe was no longer a quiet sea. It became a storm of light and energy, shaping the next chapter of existence. These first stars lived fast and died violently, collapsing into black holes or scattering their enriched matter into space through colossal supernovae. The elements forged in their hearts, carbon, oxygen, iron, were thrown into the void, seeds for planets, for oceans, for life itself. It was a fragile beginning. Much of the cosmos remained untouched by light, still wrapped in its ancient mist. But the chain reaction had begun. From a single star's birth to 1 billion more, the universe was waking. The breath of the cosmic dawn had been taken, and nothing would return to the stillness that came before. The dark would come again, in pockets, in shadows, but it would never again own the universe entirely. From here on, the stage was lit, and the great story could unfold under the glow of countless suns.
Before there were stars, the universe was a quiet ocean of cooling matter and invisible radiation. It was vast, but not yet bright. A realm where light could not travel freely, where every photon was caught in the grip of charged particles scattered endlessly in a fog-like plasma. This period was known as the Cosmic Dark Ages, but not because there was no light. Light existed, but it was trapped, unable to roam the young cosmos. As the universe expanded, it cooled, and in that cooling came a transformation. Around 380,000 years after the beginning, protons and electrons began to pair into neutral atoms, mostly hydrogen and helium. The fog lifted. Photons, no longer scattered by free charges, were released in every direction. The universe, for the first time, became transparent. What we now call the cosmic microwave background was born, an afterglow still stretching across the sky, carrying the first visible whisper of creation. Yet this was not the light of stars. It was a pale, uniform glow, soft and almost featureless. To have true brilliance, the cosmos needed something else.
gravity's patient work. In the vast stillness, small ripples of density began to pull matter together. Hydrogen clouds, growing under their own weight, compacted over millions of years. The pressure rose, the heat climbed, until deep within these clouds, fusion flickered into life. Hydrogen atoms collided with such force that their very cores merged, releasing torrents of energy. The first stars were nothing like our sun. They were giants, hundreds of times its mass, burning with blinding intensity. Their light cut through the darkness, their radiation transforming the universe around them. The ultraviolet waves they emitted began to ionize the surrounding hydrogen, breaking atoms apart and slowly reionizing the intergalactic medium. It was a cosmic awakening, the fog of darkness replaced by the fierce glow of stellar birth. These first stars lived fast and died young. Some lasted only a few million years before collapsing under their own gravity, exploding as supernovae, seeding the surrounding space with heavier elements, carbon, oxygen, iron, the raw ingredients for planets and eventually life. In their death, they ensured that the next generation of stars would be richer in complexity, able to host worlds with more than just hydrogen and helium. The day the universe learned to shine was not a single day at all, but a slow unfolding. Over hundreds of millions of years, more stars were born, more galaxies assembled, and light carved deeper paths into the void. The darkness never returned in full. From then on, the universe was a theater of illumination, a place where gravity sculpted matter into suns, and where each sunrise on every future world would trace its ancestry back to those first cosmic flames. And though we live billions of years later, we are still surrounded by that legacy. Every atom of light in our night sky is a reminder of the moment when the universe first opened its eyes, when the endless dark was broken by the glow of creation's earliest fires.
Before there were planets, before the swirling dust of galaxies came together into the shapes we now know, gravity lay silent, like a musician who had not yet lifted their instrument. It was there, woven into the very mathematics of reality, but it had no song to play. There was no mass to pull, no star to orbit, no world to cradle. And yet, the potential for everything was hidden within its quiet presence. We often think of gravity as a force, a pull, a kind of cosmic glue, but in truth it is the bending of the stage on which all things move. Imagine a vast, invisible fabric stretched out in every direction. Place nothing upon it, and it remains perfectly flat. But the moment a stone, a drop of matter, even a flicker of energy touches it, it dips, it curves, and the dance begins. That is what gravity was waiting for, the dancers. And then, in the earliest breath of the universe, particles began to form, not in isolation, but in clouds, clusters, and rivers of matter. Every piece had its own tiny tug, and these tugs began to speak to one another. Like whispers in a silent hall, they reached across space, pulling together, folding the fabric of space-time into valleys and hills. In these valleys, matter began to roll inward, spiraling closer and closer until the first great structures emerged. These were not yet planets or stars, but seeds, dense knots of hydrogen and helium, drawn together by nothing more than the patient hand of gravity. Over millions of years, these knots tightened, heated, and burned with light. The first suns were born. Around them, dust swirled in shimmering halos, colliding, fusing, breaking apart, and fusing again. Each collision was a whisper of creation, a spark in the slow work of world-making. Gravity is patient.
It does not rush. It does not hurry the story along. It shapes by waiting, by holding things close, by letting time do the heavy lifting. Over billions of years, the dust and stone circling those newborn stars grew heavy enough to claim their own space. Planets began to appear, some rocky, some made of gas, some cloaked in ice, and each one was a story in itself, a place where chance and chemistry might someday give rise to oceans, to air, even to life. Our own planet was once nothing more than a lump of molten rock, spun together from the same ancient cloud that gave birth to our sun. Gravity shaped it, held its atmosphere close, pulled water into its low places, kept its moon in a gentle orbit. Without gravity's dream, there would be no ground beneath our feet, no seas, no mountains. Without it, we would still be scattered dust. And yet, there is a mystery in gravity. It is the weakest of the universe's forces, and still it holds galaxies together. We cannot shield ourselves from it, we cannot turn it off, and we still do not fully understand why it exists at all. Some theories suggest it is not a force at all, but simply the geometry of the cosmos, the natural shape that space-time takes in the presence of energy and mass. Others whisper of extra dimensions where gravity leaks through from unseen worlds. Perhaps, in the earliest moments of time, gravity was not simply waiting for matter. Perhaps it was dreaming of the shapes it could make, of the spirals of galaxies, the slow orbits of moons, the quiet tides. Every mountain and ocean, every stone and star is the echo of that first dream. In the end, everything falls, not in despair, but in belonging. To fall is to be drawn closer, to be held, to be part of a whole. Planets fall into the embrace of stars, stars into the arms of galaxies, and galaxies themselves into larger structures beyond our comprehension. We are part of that same falling, bound by the same gentle hand. And so, the story of gravity is the story of homecoming. Every atom in your body has been falling for billions of years, and it will continue to fall for billions more. Gravity does not let go. It remembers. It keeps.
Before there was expansion, before there was light, there may have been a pause so vast that it cannot be measured. Not a pause as we know it, not the gap between one heartbeat and the next, but something older, deeper. The ancient philosophers spoke of it as an inhalation, a gathering in of all that would ever be. They imagined the universe as a great lung, drawing in the infinite, holding it for a moment that was neither time nor eternity. And in that held breath, everything was possible, but nothing yet real. We might think of it as a moment of silence before a symphony, when the air is heavy with expectation. But this was no concert hall. It was the womb of existence itself, a stillness so complete that even the idea of movement had not yet been invented. And yet, within this stillness, something stirred. Not because it wanted to, desire had not yet been born, but because potential, by its nature, cannot remain still forever. Physics has no formal word for this ancient pause, though certain theories hint at it. In some models, the universe could have existed in a state of false vacuum, a perfectly balanced field, brimming with latent energy, waiting for a small disturbance to tip it into creation. This false vacuum would not be nothing, but rather a kind of perfect something, smooth, featureless, undisturbed. And then,
Like a pinprick in the skin of reality, symmetry would break, and the universe would tumble forward into being. But the pause is as important as the expansion. Without it, there is no contrast, no way for the newborn cosmos to feel the difference between stillness and motion. In this sense, the pause is the teacher, the first boundary, the invisible line that divides before from after. Perhaps that is why so many creation myths speak of a cosmic breath. They may not have had equations or particle accelerators, but they felt, in the marrow of their storytelling, that the world could not begin without a moment to gather itself. In the Hindu cosmology, the god Vishnu sleeps upon an endless serpent in the ocean of milk, breathing in and out universes with each cycle. The Norse spoke of Ginnungagap, the yawning gap between fire and ice where nothing yet lived. The Taoists described the great void, Wu-Ji, from which yin and yang first emerged. These are not identical ideas, but they rhyme. Across cultures, there is an understanding. Before creation, there is a space, not empty, but full of the unborn. From a scientific point of view, we can wonder whether such a breath could have a physical form. Could the pre-universe have been a quantum field in perfect equilibrium, with no time as we understand it, only potential energy suspended in a changeless state? Could it be that what we call the Big Bang was less an explosion and more a release, the exhalation after infinite holding? We will never hear that breath. Even the earliest light we can observe comes long after this pause would have ended. And yet, there may be whispers of it in the structure of space itself, in the background fluctuations of the cosmic microwave radiation, or in the delicate patterns of gravitational waves that ripple through the void. If those signals exist, they are faint beyond imagination, the ghost of an inhalation, frozen in the bones of reality. In fact, and yet, if the universe began by inhaling, how long will it take before it exhales again?
Before there were atoms, before there was light, before anything that could be touched, weighed, or measured, there was only the void. Not empty, not silent, not even still, but something stranger, an expanse without space, a pause without time, and a presence without form. This void was not a vacuum, for a vacuum exists within a universe, and here the universe had not yet begun. Instead, it was a stage without actors, a book without words, a melody waiting for its first note. Yet somehow, within this nothingness, a kind of quiet potential stirred, like the unspoken thought in the mind of a storyteller who has not yet chosen where to begin. Scientists, poets, and mystics have all tried to give the void a language. They have called it the quantum field, the womb of creation, the zero-point sea. In physics, the void is never truly empty. It teems with fluctuations, whispers of energy that appear and vanish, like sparks that flicker before you can see them. The equations tell us that this quantum foam is restless even when nothing else exists, jittering with particles that blink and out of being in timescales so small they cannot be measured in seconds, only in Planck intervals, a span so brief that the human mind cannot truly hold it. And yet, it is from this restless nothing that reality begins to shape itself. The language of the void is not sound because there was no air to carry it. It is not light because photons had no path to travel. Instead, it is written in probabilities and waveforms, in the strange mathematics that allow something to be in more than one state until it is observed, and even then it resists being pinned down. To listen to the void is to interpret the curves and swirls of these invisible equations, to understand that what we think of as solid is nothing more than patterns vibrating in an unseen ocean. Imagine standing at the edge of a shore where the sea has not yet been filled with water. You hear no waves, feel no breeze, yet you sense the faint pull of a tide that has not yet begun to rise. That is the void's language, an unspoken promise that something is about to emerge, that form will rise out of formlessness. Every potential particle, every galaxy, every life that would ever exist is contained here as a possibility, like letters waiting to be arranged into a sentence that has not yet been spoken. Some traditions speak of the void as divine, others as a cold mathematical inevitability. Perhaps both are true. Perhaps the void is both a creator and a mirror, both the source of existence and the reflection of what will come. It does not speak to us in the way we understand speech. It speaks by becoming. And so, before the first particle was born, before the first photon found its way through the newborn darkness, the void held its quiet conversation, not with us, not even with itself, but with the laws of reality that were about to unfold. And in that silent exchange, the first instructions were given, not in words, but in the deep, untranslatable grammar of existence itself. If you could hear it, if your mind could somehow tune into the moment before creation began, you might not recognize it as sound at all. It might feel more like a thought crossing your mind, or a memory you've never had. It would be the first and oldest message ever sent, and perhaps the most important. From nothing, something will come. And it will speak in a language that you, being part of it, will someday understand without ever needing to learn it.
Silence is not the absence of sound, not here, not in the infancy of everything. In those earliest moments, before the atoms knew their names, before light learned to travel, there was a stillness so complete it could hold the weight of all futures. It was not empty, it was listening. The forces that would come to rule the cosmos, gravity, electromagnetism, the strong and weak nuclear dances, had not yet settled into their patterns. They moved carefully, almost shyly within a cradle of quiet. And in that quiet, something extraordinary happened. They began to speak to one another, not in words or light, but in the silent alignment of laws. We imagine the young universe as chaos, heat and collision, expansion without end. But maybe, beneath that storm, there was a deeper layer, a resting heartbeat, the kind of pause that lets a seed split open in the dark before it reaches for the sun. Without this pause, without this shared breath between forces, perhaps nothing could have cohered at all. Stillness, in physics, is an illusion. Even in the space between stars, particles drift, quantum fields tremble, and gravity never sleeps. But there are kinds of stillness that matter. The slow cooling of plasma into neutral atoms, the stabilizing of orbits, the long, quiet spans where nothing changes except the readiness for change. This was the silence of becoming, the kind that shapes rather than erases. Perhaps silence was the first architect. It gave gravity time to weave its invisible net. It gave the strong force time to lock protons and neutrons together, and the weak force time to rehearse its delicate, rare transformations. In that quiet rehearsal, balance was struck.
not because the forces chose it, but because the stillness left them no choice except to find harmony. We know now that sound is just the vibration of air or water or stone. But in a universe without such mediums, silence was not a lack, it was the only constant. And maybe, in ways we can't measure, that constant guided the unfolding, as a conductor guides an orchestra before the first note is sung. Even now, across billions of years, the universe remembers that stillness. We see it in the cold, dark gulfs between galaxies, where nothing stirs for eons. We feel it in the ocean trenches, where sound dies within a few body lengths. We sense it in our own moments of pause, when thought suspends itself just long enough for clarity to enter. Stillness is not the opposite of motion. It is the frame in which motion finds meaning. And maybe, just maybe, without that early silence, the universe would have been noise without form, a chaos that never cooled, never slowed, never allowed matter to hold itself together long enough for stars to be born. Perhaps silence is not what comes after creation, but what makes creation possible at all. The ancient astronomers spoke of the music of the spheres, imagining that planets and stars sang as they moved. But what if the first music was not sound, but the waiting before sound? The way a deep breath gathers in the chest before a single note is sung. We live in a cosmos that still carries both its noise and its hush. Every heartbeat is a rhythm shaped by a pause. Every galaxy spins between the great silences of space. And perhaps the story of everything we know, every planet, every ocean, every breath, is a story born not from the roar of creation, but from the quiet that shaped it. And yet, if silence can shape everything, what happens to time itself in a place where there is no one to hear it pass?
Time is often thought of as the steady tick of a clock, a reliable rhythm marking moments one after another. But what if time, without someone or something to observe it, slips quietly away, without meaning, without measure? Imagine a universe where there is no witness, no memory, no eyes or minds to hold time's fragile thread. Does time still flow, or does it dissolve into silence? In physics, time is deeply intertwined with observation. Relativity shows us that time bends and stretches, changing its pace depending on who watches it and from where. Without an observer, the concept of past or future begins to blur. The universe might be flowing endlessly, but if no one is there to measure its passage, does it make a sound? Does it even exist in the way we understand? Entropy, the ever-quiet march toward disorder, depends on differences, changes that can be noticed, recorded, or felt. But in a silent cosmos with no witness, could entropy still rise? Or does the arrow of time lose its direction, becoming a gentle back and forth, a wave without a shore? Imagine a vast ocean, calm and still, stretching beyond sight. Waves ripple endlessly, yet no one stands on the shore to see them crash. Without the watcher, the story of each wave remains untold. Time might ripple similarly, an unseen dance of moments fading into one another, unheard, unseen, unremembered. The universe itself could be the ultimate observer, quietly registering its own unfolding.
But what does it mean for a cosmos to watch itself? Can the vastness of space hold a mirror to the flow of time? Or is time's meaning lost without a conscious witness to hold it close? Our own lives are marked by memories, snapshots of moments recorded in the quiet chambers of the mind. Without memory, time would slip through our fingers like sand, ungrasped and unheld. On the grandest scale, could the universe have a memory? Does it store echoes of moments past in the light of distant stars, the fossilized trails of isotopes, or the deep, slow rhythms of planetary shifts? If we accept that time needs a witness to truly exist, then the cosmos itself is a delicate balance between motion and meaning. The ticking of time requires an ear to listen, an eye to see, a mind to remember. Without us, or something like us, the river of time might flow endlessly, but it might also flow silently into nothingness. And yet there is a strange comfort in imagining time without a witness. It is a time free from judgment, free from the weight of expectation, a time that simply is, without past regrets or future hopes, without the need to be measured or understood. In that quiet, perhaps time takes on a new shape, a new purpose, one that whispers softly through the spaces between stars. If time can exist without a witness, then maybe time is not a strict line or a steady pulse. Maybe time is a breath held in the universe's chest, a soft vibration felt only when we pause to listen. It might be less a thing to grasp and more a presence to be felt, a gentle unfolding of existence itself. And as we ponder the nature of time and witnessing, we begin to ask, if the universe watches itself, if time unfolds in silence without an audience, what then is the true measure of existence? What holds the moments together when no one is there to hold them? These questions drift quietly in the vastness, inviting us to imagine not just time as we know it, but time beyond our senses, time without a witness, and yet somehow still flowing.
Light has long been our cosmic messenger, traveling vast distances to bring us stories from the edge of the universe. But what if there are echoes older than light itself? Patterns, ripples that predate even the first photon's journey, whispering secrets from the very first instant of existence. These are the gravitational waves, faint murmurs in the fabric of space-time, carrying the memory of creation's earliest breath. We tend to think of the universe as a silent stage where light shines and shadows fall. Yet, beneath this quiet play, the cosmos hums with vibrations that do not rely on light or matter. Gravitational waves ripple through the void like ripples on a pond, carrying the imprint of colossal events, colliding black holes, the birth cries of stars, even the trembling echoes of the Big Bang itself. Imagine these waves as the universe's oldest song, sung long before light could escape the fiery furnace of creation. They move through space not as light, but as distortions in the very shape of space-time, bending and stretching it gently, invisibly. They travel with no need for air or matter, crossing the emptiest voids without losing their voice. The discovery of gravitational waves opened a new window to the past,
allowing us to listen to moments that were once unreachable. These waves are cosmic fossils, vibrations fossilized in time, carrying stories older than the stars. They are whispers from the dawn, telling us of a universe in motion before light had the chance to shine. Could these echoes carry more than just stories of cosmic collisions? Could they hold clues to what came before? Some scientists wonder if the gravitational waves we detect are like ripples from a pond disturbed before the water even settled. Traces from a time before time, from the chaotic birth of space-time itself. These waves remind us that the universe is not static, but alive with movement, that silence is never complete. Even in the deepest darkness, the cosmos pulses with a rhythm, a heartbeat older than light, older than matter. It is a rhythm that carries the memory of beginnings, a memory that may never fully fade. As we tune into these ancient echoes, we find ourselves connected to the universe in a new way, listening not just with our eyes, but with our whole being. The waves ripple through us as they ripple through space-time, inviting us to remember the silence before light, the pulse before form. And yet, as these whispers travel across billions of years, one wonders what other echoes lie hidden, waiting for us to hear them. What stories remain buried in the folds of space-time beyond the reach of light and sound? The cosmos is vast, and its history deeper than we can imagine. Each gravitational wave is a breath from the universe's past, a soft vibration that carries the weight of untold mysteries. They are not just echoes older than light, but echoes of the universe's earliest dreams. And as we listen to these ancient murmurs, we find ourselves suspended between what is seen and what is felt, between light and silence, forever chasing the echoes of a time long vanished.
Before time began, before space was measured or shaped, there was no direction, no up or down, no left or right. Imagine a vast formless sea where every point was the same, where the universe held no compass, no map to guide the unfolding of its story. In that timeless silence, symmetry reigned supreme, and the cosmos waited patiently for the first sign of difference. Symmetry is the quiet language of balance, where every part mirrors another, perfect and whole. But the universe, in its restless creativity, had to break this silence, to shatter this mirror, in order to become what it is. The first directions emerged, not with thunder or light, but with a delicate, invisible fracture, a subtle shift where the sameness cracked open and space itself gained shape. Physicists call this symmetry breaking, a whispered rebellion in the fabric of reality. From this gentle fracture, the three dimensions we now inhabit, length, width, and depth, bloomed into being, each one carving a path for matter, energy, and time to follow. Without this breaking, there would be no stars to gather, no planets to spin, no life to dream. Imagine a blank canvas, smooth and endless, suddenly touched by the faintest brushstroke. That stroke is direction. It guides the dance of particles, steering them from chaotic movement into patterns of order. It sets the stage where gravity can pull, where light can travel in a straight line, where the cosmos begins to tell its story with form and purpose.
This emergence of direction is more than geometry. It is the birth of possibility itself, the first whisper of choice in a universe poised between infinite sameness and vibrant diversity. Without direction, nothing could fall, nothing could rise, and nothing could change. But with it, the seeds of galaxies, stars, and even consciousness were planted. In these first moments, space was not yet the smooth, continuous expanse we know today. It was restless, vibrating with potential, folding and unfolding like a living thing. Direction gave it shape, but it was still fragile, still learning how to hold its new form against the pull of entropy, the slow unraveling of order into chaos. We carry echoes of this ancient breaking within us. Every movement we make, every step we take, follows the directions carved out billions of years ago. Our very perception of up and down, near and far, depends on this cosmic fracture. It is a silent compass embedded deep within the fabric of our being. And yet, direction is not fixed or absolute. In the vast stretches beyond our sight, space bends and warps, and what seems straight in one place curves in another. The early breaking gave us dimensions, but those dimensions dance and shift, reminding us that even direction is a story still unfolding. Could it be that before this first fracture, the universe existed in a state beyond all our understanding, where direction was a dream not yet dreamt, where space was a whisper without shape? Is it possible that the very act of breaking symmetry was the universe's first act of creation, a quiet choice that made everything else possible? As we stand in the vastness, looking out into the night sky, we trace the paths of stars and galaxies, following the directions that emerged in that silent breaking. Each point of light is a reminder of the universe's first decision, its gentle shaping of space into something new and endless. And yet, even with all this order, the universe remains a place of mystery, where the boundaries between chaos and calm, between sameness and difference, continued to blur and blend. Direction is both a gift and a question, a line drawn in the fabric of existence, inviting us to wonder what lies beyond. The cosmos is a map still being drawn, its first directions the faintest strokes on a canvas that stretches beyond time and space. And as we follow those strokes, we begin to understand not just where we are, but how the universe found its way from nothingness into everything.
The universe holds its history not only in stars and galaxies, but in the smallest grains of dust that drift silently across ancient rocks. These tiny remnants carry whispers from the dawn of everything, stories written not in words, but in isotopes, subtle variations in the very atoms themselves. In these quiet markers, the cosmos has drawn a map, a delicate script that guides us back through time, tracing the earliest chemical events that shaped all we know. Imagine holding a speck of dust, so small it slips easily between your fingers, and knowing that within it lies a story older than continents, older than the oceans, older even than the sun. These particles are cosmic messengers, fossilized fragments that survived storms of fire and rivers of ice, carrying secrets of epochs long forgotten. Isotopes are nature's fingerprint, slight differences in atoms that reveal the passage of time and the transformations of matter. They record the rise and fall of elements forged in stars, the subtle changes wrought by cosmic rays, and the slow decay marking the relentless flow of entropy. Each isotope is a note in the symphony of the universe's past, resonating softly in the dust. In the quiet embrace of these particles, we find evidence of processes invisible to the naked eye, a slow choreography of atoms and molecules dancing through eons. Through their patterns, scientists unravel the mysteries of early atmospheres, shifts in climate, and the silent wars of chemical bonds that paved the way for life. Yet, this map is not fixed or complete. Dust drifts endlessly, its particles moved by winds, tides, and the pull of gravity, erasing some traces even as it preserves others. It is a fragile archive, vulnerable to loss, decay, and the ceaseless march of time. What has been forgotten might still linger in the folds of these ancient grains, waiting for us to listen carefully. Could these isotopes be echoes of a time before recorded history, fragments of a world we will never fully know? Is it possible that the dust beneath our feet is a repository of lost wisdom, holding memories not just of stars and rocks, but of the very processes that shaped existence? The more we look, the more the dust reveals its quiet stories. Not loud declarations, but soft, rhythmic pulses that connect us to the vastness. The universe writes in silence, its messages scattered like stardust across the fabric of reality. And as we trace this map in the dust, we are reminded that history is not always found in grand monuments or blazing light. Sometimes it is written in the quietest places, the tiny grains, the slow decay, and the invisible shifts that together hold the memory of everything. And yet, if this much can be lost, what else might we have forgotten?
Before our sun ever warmed the skies, before Earth spun its quiet orbit, countless stars lived brief, brilliant lives and then faded into silence. Their light, once fierce and unyielding, has long since vanished, but their ashes remain, scattered fragments of ancient fire that now shape the mountains we climb, the oceans we sail, and the very bones that carry our memories. In the quiet aftermath of these forgotten stars, we find the true legacy of creation. Stars are cosmic forges, where the raw elements of the universe are transformed by unimaginable pressure and heat. Within their cores, hydrogen fuses into helium, and heavier elements, carbon, oxygen, iron, are born from the crucible of nuclear fire. When these stars exhaust their fuel, many end in spectacular explosions, scattering their enriched guts into the vastness. This stellar debris becomes the dust of worlds, the building blocks of planets and life itself. Imagine the siloed voyage of these ashes, cast out across the darkness, carried on waves of gravity and time. Over billions of years, this scattered matter coalesced, swept into swirling clouds of gas and dust. These clouds collapsed under their own weight, igniting new stars and forming the planets that circle them. Our own world, with its oceans and mountains, is made of this ancient stardust, the remnants of lives long extinguished. In every grain of sand on a beach, in every breath we take, there is a trace of these long-lost stars. Their lives ended, but their influence endures, woven into the fabric of our very being. We are, quite literally, children of the ashes, carrying in ourselves the story of explosions that happened before human history even began. And yet the story is not one of finality, but of transformation. The ashes of forgotten stars are not mere remnants, but seeds of renewal. In their quiet dispersal, they sow the universe with the potential for new beginnings. Mountains rise from the dust, oceans gather beneath the sky, and life takes hold in ways we are only beginning to understand. Could it be that these ashes carry more than elements, that they bear a kind of memory, a subtle record of the stars' fiery lives and deaths imprinted in the isotopes and minerals that make up our planet? Is it possible that within this cosmic sediment lies a silent archive of the universe's earliest epochs, waiting patiently for us to discover? As we gaze into the night, we look not just at distant points of light, but at the echoes of countless stars that came before, ghosts whose ashes now shape the world we call home. Their story is written not in loud explosions or bright flares, but in the quiet persistence of dust and stone, in the steady cycle of creation and decay. In this ancient legacy, there is a profound sense of connection, a thread that links the stars' final moments to our first breath, to the slow unfolding of life on Earth. We are part of a vast cosmic cycle, born from ashes and destined to return to them, carried onward by the endless flow of time. And yet, as we contemplate this shared history, one wonders, what other remnants of forgotten stars lie hidden in the shadows? What stories do their ashes still hold, and how might they illuminate the mysteries of our own existence? The universe is a vast tapestry woven from light and shadow, birth and death, fire and ash. And in the ashes of forgotten stars, we find a quiet testament to the enduring power of transformation, a reminder that from endings come new beginnings, and that even the most distant past lives on within us.
Memory is often thought of as a human gift, a flicker of thought, or a whisper of experience held deep within the mind. But what if memory is older than us, older than life itself? What if the universe began its long, gentle act of remembering far before consciousness ever stirred, writing its story into the bonds of atoms and the rhythm of cosmic cycles? From the first atomic bonds that formed in the quiet depths of space, the universe began a subtle dance, one that held traces of what came before, echoes woven into the fabric of matter. These bonds, delicate and patient, capture moments in time, storing information not in words, but in structure, in arrangement, in the very nature of connection. We can think of this as a kind of memory, a silent record etched in the relationships between particles. Each atom remembers the forces that shaped it, the energy it has exchanged, the cycles it has survived. Over vast stretches of deep time, these tiny memories accumulate, building a history far beyond human reckoning. In the slow birth of memory, nothing is hurried. Information is passed along not in sudden leaps, but in gentle waves. Chemical signals that ripple through primordial clouds. Changes in isotope ratios that mark ancient climates. The fossilized whispers preserved in stone. Each fragment carries a trace, a hint of the past that invites us to listen closely. From these ancient records, life itself began to emerge, carrying forward the universe's capacity to remember. DNA, that elegant molecule of life, is a profound extension of this cosmic memory, a code that holds the blueprint of generations, a slow unfolding story written in the language of chemistry. And yet, memory is not just a passive archive. It is a living, breathing process. It grows, adapts, and transforms with each new experience, weaving past and present into a tapestry of identity. The universe's memory, too, is dynamic, a flow that shifts as stars burn, planets change, and life evolves. Could it be that memory is the thread that connects us to the cosmos, a bridge between the smallest particle and the vastest galaxy? Is it possible that in the act of remembering, the universe becomes aware of itself, tracing its own history through the minds of those who listen? As we drift through this quiet reflection, we realize that memory is both fragile and enduring. It can fade like a whispered secret, lost in the winds of time, or it can endure like the oldest fossils, silent but steadfast beneath layers of rock. And so, the slow birth of memory is a story without end, a continuous unfolding that invites us to wonder what has been preserved, what has been forgotten, and what might yet be remembered in the stillness of the universe. And yet, if memory can be born so slowly, might there be depths of remembering still hidden from us, waiting patiently in the silence?
The idea of edges, boundaries where something ends and nothing begins, feels natural to us. We see edges in the world around us, the horizon where sky meets earth, the shore where land kisses sea. But what if the universe itself has no edges? What if space and time stretch endlessly, looping and folding in ways that defy our simple understanding? In this vastness, a beginning becomes harder to imagine, and the question of origin unfolds into something far more mysterious. Imagine a universe without boundaries, where traveling far enough in any direction might bring you back to where you started, like walking in a circle beneath a sky without end. Such a cosmos challenges the idea of a fixed starting point, a singular moment of creation. Instead, it suggests cycles, endings that lead to beginnings, moments that ripple through eternity in quiet, infinite loops. This concept stretches deep into the fabric of modern science, where theories of cyclic time and infinite space challenge our perceptions. Some models propose that the universe expands and contracts, breathing slowly in vast cosmic rhythms. Others imagine a multiverse, where countless universes emerge, fade, and return in endless succession. In such a universe, time may not be a straight line, but a curve, a spiral that bends back upon itself. This reshapes how we think about before and after, cause and effect. Without edges, there is no final boundary to hold us, no definitive first moment to anchor existence. Instead, we float within an eternal dance of creation and dissolution. This infinite tapestry may also hold the key to entropy, the slow drift toward disorder that governs all things. If the universe cycles endlessly, could entropy reset itself in moments of cosmic rebirth? Could the ashes of one universe become the seeds of another, each cycle weaving a new pattern from the threads of the old? The absence of edges invites a humility, a quiet acknowledgement of our place in an unbounded whole. It asks us to let go of the need for clear beginnings and endings, to embrace mystery and the unknown.
Perhaps the universe is less a story with a start and finish, and more a melody without end, notes that rise and fall in an endless, gentle song. Could it be that our minds, bound to linear time, can only glimpse a fraction of this vastness? Is it possible that the true nature of existence lies beyond our perception, hidden in the folds of infinite space and time? As we consider a universe without edges, we find ourselves suspended between wonder and silence. The cosmos, vast and ending, invites us to listen closely to the spaces between stars, the quiet flow of time, and the soft pulse of infinity. And yet, if there are no edges, what does it mean to begin at all?
Time often feels like a river, flowing steadily from past to future, carrying moments like leaves on a current. Yet, what if time is not a simple line, but something shaped, curved, twisted, or woven into patterns we cannot easily see? Imagine time as a spiral or a loop, bending back on itself, folding into hidden dimensions beyond our everyday experience. Such a view reshapes our sense of what before truly means. In physics, time is more fluid than we often imagine. It can stretch and compress, slow and speed up, depending on where we are and how fast we move. This flexibility hints that time's nature might be more complex, more like a fabric that can fold or ripple. If time has shape, then beginnings and endings might blur, connected in ways both subtle and profound. Could time curve around itself like a ribbon, allowing moments long past to touch the present in quiet echoes? Could what we call memory or anticipation be glimpses into these folds, brief crossings between times that seem separate but are deeply linked? This invites us to imagine a universe where time is not a one-way path, but a landscape we can wander, sometimes forward, sometimes back, sometimes around. The shape of time may hold clues to deep cosmic mysteries. It might explain how the universe can be both vast and intimate, infinite yet connected. If time is curved, then the before of the universe could be wrapped within the after, and beginnings may be endings disguised. This poetic vision invites humility and wonder, reminding us that our perception is just one thread in a larger, more intricate weave. As we ponder time's shape, we find ourselves moving gently between certainty and mystery. The steady tick of the clock is a guide, but it does not reveal the full story. Time may be a spiral staircase, a Mobius strip, or something stranger still, shapes that challenge the boundaries of our understanding and open us to the unknown. And yet, if time is shaped like this, what paths might we be walking without knowing it? What connections might lie hidden in the folds of moments, waiting for us to discover?
If we could step beyond the flow of time itself, what would we find? Imagine looking out over a landscape where yesterday, today, and tomorrow dissolve into a single quiet moment, a place beyond beginnings, beyond endings. This is the realm of meta-time, a speculative space where the usual rules of before and after no longer apply, and the question of the universe's origin takes on a new, profound dimension. In this stillness, time as we know it pauses, folds, and perhaps even unwinds. The first day of the universe, the moment of the Big Bang, might not be a true beginning, but a threshold, a surface beyond which our understanding fades into mystery. Could there be a reality where the concept of time itself is a ripple on a deeper ocean, where the day before the first day is not an impossibility, but a different kind of existence altogether? Science hints at such possibilities through theories that extend beyond classical time. Some models propose dimensions outside our perception, layers where time is not linear but multidimensional, a landscape rich with unseen paths. In these realms, beginnings may be shadows, and what we perceive as the birth of time could be a transformation, a door opening from a hidden state into the universe we know. This challenges the comforting notion of a single starting point. Instead, it invites us into a meditation on thresholds and transitions, moments where one reality blends softly into another. The day before the first day becomes a symbol of mystery, a space where cause and effect loosen their grip, and the universe waits quietly in a breath before becoming. Could this moment hold the seed of everything, not just matter and energy, but the very laws and constants that govern existence? Might it be a realm where possibility is infinite, where the potential for creation stirs in silent anticipation? And if so, could the universe be an unfolding dream, a story told from a place beyond time, whispered into being with the soft breath of beginnings? As we imagine this threshold, the edges of knowledge blur, and we find ourselves suspended between what we know and what we wonder. The day before the first day is not a point on a calendar, but a question posed in silence, an invitation to explore the unseen spaces of reality. And yet, if such a place exists, what might it teach us about the nature of existence and the meaning of time itself? If we could step beyond the flow of time itself, what would we find? Imagine looking out over a landscape where yesterday, today, and tomorrow dissolve into a single quiet moment. A place beyond beginnings, beyond endings. This is the realm of meta-time, a speculative space where the usual rules of before and after no longer apply, and the question of the universe's origin takes on a new, profound dimension. In this stillness, time as we know it pauses, folds, and perhaps even unwinds. The first day of the universe, the moment of the Big Bang, might not be a true beginning, but a threshold, a surface beyond which our understanding fades into mystery. Could there be a reality where the concept of time itself is a ripple on a deeper ocean, where the day before the first day is not an impossibility, but a different kind of existence altogether? Science hints at such possibilities through theories that extend beyond classical time.
Some models propose dimensions outside our perception, layers where time is not linear but multidimensional, a landscape rich with unseen paths. In these realms, beginnings may be shadows, and what we perceive as the birth of time could be a transformation, a door opening from a hidden state into the universe we know. This idea challenges the comforting notion of a single starting point. Instead, it invites us into a meditation on thresholds and transitions, moments where one reality blends softly into another. The day before the first day becomes a symbol of mystery, a space where cause and effect loosen their grip, and the universe waits, quietly, in a breath before becoming. Could this moment hold the seed of everything, not just matter and energy, but the very laws and constants that govern existence? Might it be a realm where possibility is infinite, where the potential for creation stirs in silent anticipation? And if so, could the universe be an unfolding dream, a story told from a place beyond time, whispered into being with the soft breath of beginnings? As we imagine this threshold, the edges of knowledge blur, and we find ourselves suspended between what we know and what we wonder. The day before the first day is not a point on a calendar, but a question posed in silence, an invitation to explore the unseen spaces of reality. And yet, if such a place exists, what might it teach us about the nature of existence and the meaning of time itself?
Before the stars sparkled and matter found form, before the pulse of time began to steady, could consciousness have existed in some strange, nascent way? Could the universe, in its earliest moments, have dreamed of itself, a quiet, unspoken awareness woven into the very fabric of existence? This poetic thought invites us to consider a bridge between physics and philosophy, a moment where the cosmos and mind might be softly entwined. Consciousness often feels like something uniquely human, a bright flame flickering within us. But what if it is older than life, older even than the atoms that dance in the void? Perhaps it is a subtle thread running through the universe, a whisper beneath the roar of creation, a stillness that existed before the first breath of matter. In this imagining, the universe is not just a collection of particles and forces, but a dreaming entity, a cosmic self-awareness that unfolds slowly, patiently. Like a seed held deep in the soil, this dream waits quietly, gathering light and energy until it begins to blossom in the form of stars, planets, and life. Could this dream be the source of the mysterious order we see in the cosmos, the elegant laws that guide galaxies, the symmetry in nature's patterns, the hidden harmony in chaos? Is it possible that consciousness and creation are two sides of the same cosmic coin, reflections of one another in a vast unfolding story? As we drift through this quiet wonder, we feel the universe not as a cold machine, but as a living, breathing presence, a vast dreamer whose thoughts ripple through time and space. This dream is fragile, yet enduring, elusive, yet persistent. It holds questions that may never be answered, but that call to us with a soft, persistent light. And yet, if the universe dreamed of itself, what shapes might those dreams take? Could we be the echoes of that ancient dreaming,
reflections of a cosmic mind learning to know itself through the slow unfolding of time.
Before words existed, before thought shaped itself into questions, could there have been a moment when the universe itself posed the very first question? A silent, profound wonder, not spoken aloud, but felt deep within the folds of reality, stirring the laws of physics and the flow of time towards something new. This idea draws us into a realm where the boundaries between mind and matter blur, where the universe contemplates its own becoming. What does it mean to ask a question? To seek meaning beyond what is already known? Could the very fabric of existence hold within it a primal curiosity, a restless impulse driving the unfolding of everything we see and sense? Perhaps the laws of physics themselves were not fixed from the start, but emerged from this early state of questioning, a shifting realm where rules were fluid, possibilities endless. Imagine a time before constants settled into place, before gravity, electromagnetism, and the other forces locked into their dance. In that shifting silence, the universe might have been a vast canvas of potential, waiting for its first question to carve out shape and order. Could the emergence of physical law be the answer to a cosmic inquiry, a response to the universe asking, "What am I?" This vision invites us to see existence not as static or predetermined, but as an ongoing process, a dialogue between the unknown and the known, the possible and the actual. The first question ever asked may be a symbol for this dance, a moment of self-awareness that set creation into motion. Could this ancient question echo still beneath the surface of reality, in the flicker of a distant star, the slow folding of a leaf, the quiet thought in your mind? Might there be traces of that primordial wonder? The universe's first question is both a mystery and an invitation, a gentle call to keep asking, to keep seeking, as we journey through time and space. And yet, if the universe began with a question, what answers might still be waiting, just beyond the edge of our understanding? Here, at the quiet edge of before, we pause. Not at an ending, not at a beginning, but at the fragile, shimmering boundary where time itself might have first stirred. It is a place both familiar and unknowable, a silent threshold that holds more questions than answers, a stillness that invites us to listen deeply. What is the thing that made time possible? What breath, what impulse whispered the cosmos awake? We often think of beginnings as solid points, moments frozen in time. But perhaps the edge of before is less a line and more a gentle mist, shifting, elusive, almost disappearing as we reach for it. It is the silent question behind all others, the quiet space where mystery gathers, where the universe holds its breath. Standing here, we confront the limits of our understanding and the vastness beyond. If time had a first moment, what came before that moment? Could there be a hidden cause, or does the question itself dissolve into the nature of time? We imagine time's first pulse as a delicate unfolding, a breath expanding outward, carrying with it the seed of all things. It is the quiet origin, the soft beginning of everything we have ever known, and yet it remains wrapped in shadow.
This edge reminds us of the fragility and beauty of existence, of countless mysteries folded into the fabric of reality. It is a place where science and wonder meet, where the language of physics brushes against poetry. In this stillness, we find humility, the acceptance that some questions may always remain beyond our grasp, inviting us to keep seeking, to keep dreaming. And so, standing at the edge of before, we are not alone. We are part of a story far greater than ourselves, a story that stretches beyond time and space into the quiet forever. Here in this moment, we listen for the whisper that began it all, knowing that some mysteries are meant to be held softly, like dust drifting on a slow breath. And yet, the question lingers, shimmering gently in the silence. What is the thing that made time possible?